Hi, my name is Robert and welcome to my first video. The reason why I'm making this is because I want to learn how to build robots before I get into college. So I am making this channel so you guys can help me out and join my journey. Let's get into it. So let's get into my plan. So I want to make a robotic arm that has the ability to grab things, right? So we know we need a base to host this arm. On this base, we need to have a servo motor, because that's what I said I'm using, to turn the arm, right? Then we need to have a height pole for the arm. Then we need to have another servo motor here, so the arm can do this. Then we need to have the upper part of the arm. And lastly, we need to have the two servo motors up here, so our arm can grab things. Then, Arduino board, bunch of wires. I'm not good at hiding wires here, so there will be a lot of wires. But that's why I'm doing this, so I can learn how to hide the wires. And I haven't figured that part out yet. And then, controller. I haven't done this yet, but I'm probably gonna make it fancy with little lights and stuff. But I want to get a rough product out there first. That will probably be a second video because I've filmed too many parts for this one already. A lot of failures. A lot of failures. But that's for me to know and for you guys to find out. So how am I going to do this? I'm going to 3D design the parts using CAD, computer assisted design. Particularly I'll be using Fusion Autodesk Fusion 360. Then I'll take this and I will print this on what you hear over there, my Bamboo 3D printer. So into Bamboo to 3D print. Then after I 3D print, I put on the hardware and motors. After the hardware and motors, I then wire. After I wire, I code. And then after I code, we get the product. Sounds like a game plan, sounds like a plan I already did, but let's get to it. Alright guys, so this is the base I first made. How I did this is what I took in this servo model from an online database, right? So I took this model, built this cube around it, made the screw holes. Then I knew that I needed a nice wide base because my robot arm is going to be moving in the air a lot. So it needs something where the force isn't going to throw it off balance. So I needed to make something quite long. So I made a nice wide base so the arm can move freely without any worry of that. Then I made sure there was space for wires and a Arduino board, which I will screw in manually. So this is a pretty basic design. No current changes to it yet. I will work on that eventually, but right now I was more concerned with the other parts. So let's move on to that. Now, the most annoying part was this, the bottom arm design. Now you'll see why this is the most annoying part. My first issue, this was the first ever design, right? This was made by my Under 3D. Look, I had to file it down. That was one of my first issues. This wasn't big enough to fit the wires in. But one of the biggest issues is I used a small servo motor. Hang on, I'll get it. One of these little bad boys right here, right? Because I was like, oh, they're pretty strong. Which it actually was strong enough to move the arm itself. But I wanted to pick up stuff, so I needed something a bit stronger. But that was one of the first issues. The second issue was, how do I attach something on here? Like yeah, it's holding the motor, but like what? Am I just gonna have it like clunky out on the side like this, and it's gonna be like like that, because like that's number one gonna look weird, and a big issue was how easily it could fall off this. This is what attached to the end of the motor. I tried 3D printing a part into the bottom, but it wouldn't work. So I would in turn have to use these and screw it on or build some sort of design. Now, yeah, it holds this on perfectly and this can rotate without problem. But I wanted to make it on. So I designed this. This is the upper arm. I was kind of jumping ahead, but it helped me a lot. So I screwed this on here. Now you see the issue with this? First of all, look how bad this is. The motor sits so far out. And obviously, as soon as I turned this thing on with electronics, fell off. So I needed to rethink. I wanted to make it middle central, and I wanted to make it so it wouldn't fall, so an external support system. That's when I came up with the circular design. I think this was my first one. You can see the problem with this one. This one was just insanely big, clunky, and it was like I was making a whole tank system. It doesn't look nice. I forgot to add supports too, but it was just like, it was a whole tank system. It didn't meet the looks, and it, you know, so much filament would be used. So that was my first version of that. Then was this. This was actually kind of perfect, right? Look, circle on here. So my idea is I have two sides, one side here, one side here. A support side and then the main side. The main side will attach to circle looking piece right here, right? So boom, motor in here, attach circle, boom, screwed on, boom, move. Now here is a problem. I had 3 of these, right? So not that many. And I stripped one of them by doing this design. It was just so much like the torque. Look how close this is to the center hole. The torque was just insane on the robot. It wasn't working with it. So it was just too much force, you know? So I resorted to an attachment that had more torque and was more farther out, you know? Specifically this one. See, it's much further out and it has much more support slots. So I could screw it out. And with that, I wanted to have room for this. So I scrapped the circle part on this and I kept it on the other side. So I have a couple of these. Oh yeah. The problem with this one is it wasn't centered at all. I actually designed this and the center was all the way up here and the wires would go up. So there was no room for that. So then I went to this design. Now I still kept the other circle thing here because I hadn't come up with my new thing yet because I thought it would work, but it didn't. So this design works is you have a little block, you slide it in, and you screw it. So the center of the motor will sit down here. So this made it so the circle was a lot smaller, it was in the center, and the wires came out of the bottom here. Perfect, it worked. A big issue was attaching it and making it a movable joint. So I tried making the star piece, didn't work. Obviously the original circle design, too much stress on the part. So it went over and over and over until I made this right here. So the star piece, I measured this myself. And then what you do is I found that there was these screws that screwed this part in to the servo. So I screwed this into the servo, put this on the outside, put all the screws in, and boom, it works like a charm. Perfect force on it, and the other side keeps it stable so it's not doing this and falling off. So, now, this sounds like very quick and like boom, he thought of that, but this took literal days. This process itself took literally 3 days, and it was just super stressful because I printed so many of these things, so much filament was used, and so many of these things too. Like this was meant for the circle design because this is the radius and 3 holes, 3 holes, 3 holes, screwed in, but then it tore the piece. But I finally came down to the final, which was this. So let's focus on the lower arm here. There's a circle on this side attaching to this, the support side. So you see how this isn't really on there? I can pull it off, but this is the support side. And then the star is under here, screwed into the servo, and then boom, I came with a perfect lower arm and It moves no problem. Supports and everything. Days and days of work on that one. Oh, and before I forget, I should probably throw in how I attach this to the base. So like I said, the little attachment parts, right? So I made a perfectly sized hole. Though I have a little drill bit that I actually had to like shave off a little, so it was like perfectly sized. But it just slides onto the top with a screwed in piece, and then the motor just moves it like that. So now, let's move on to that upper arm design, which is actually printing right over there. So that's gonna be to future me. I'll hand it to that guy. Alright, since this is a much more recent design, I can show you this because I haven't actually fully printed it. So, okay, so here's the part that I screwed in, you know, my star design, love it. Now, all I did is I made a centered circle between the other clip right here. So I found the center, and then I found the center of this, extruded a circle, I think is like 5.5 or 5 inches up, right? And then now, I know I wanted to hold two mini servos, not the big servos that I used for the rest of this, to make the claw. So, I made a cube around roughly the size of the servo. Very rough work here, by the way. I'm not really using measurements. Not too much of a pro at that yet. I'm gonna let you guys know that. But here, I extruded two sides of the servos, extruded them, right? And then I made areas for the wires to go out the bottom. This is not my final design here yet. I don't know what it would look like, but I need to find some way to get the wires all the way through and down, which can't even wrap my head around that yet. So you'll see that in probably 10 minutes or something. But here I made a slot for, pretty simple. Just extrude, make slot for two servos, boom, done, blammo. Let's move on to the next one. Alright, so this design right here, there's not too much to go into detail here. So, you know the two servo slots I just showed you here, your servo motor is there, right? Now, let's come here and take this off. So, I have two simple claw designs that I sketched up. Nothing too fancy, just two little claws, you know, try to make it look decent-ish. No, it's not perfect. But, if we look deeper here, I went into the claws here, into the back, so the servo fins, like the things I attach onto the servo, can sit perfectly flush inside of my claw, and then I make a screw hole, boom, it's amazing, right? Pretty simple. Hopefully it's very functional too. Now, the same problem I had earlier, the whole making sure it doesn't fall off, I thought about that too. That's that cap I just took off. This cap right here will make sure they're nice and pressed in. I already see an issue about the screw hole, but we'll face that challenge when it comes. I could probably do a real life fix for that. But this cap should stop them from, you know, falling off sideways like they did with that upper arm piece. And as you can see, I slitted it down here so this arm can come all the way down. But this should work pretty well. We'll see. So here's a fresh 3D print of the upper arm model that I just made. So we're going to take it out and assemble it with the lower arm model I previously had. Alright, so here's the printed upper arm piece. Now let's assemble it to the lower arm piece. This is the star piece I used to attach. We're going to take this servo motor and we're going to slide it into the slot I made. Then we're going to slide a plastic piece over that I'll show you here in a second. This is the block that we're going to slide over the top of the motor, then we're going to screw it into the top servo holes to keep the motor in the print. Okay, so now that I have the motor in place, I'm going to take the star piece that I showed you earlier and use the special black screws to screw in the star piece so it won't wobble around or strip the piece. Alright, so here's the new printed upper arm that we just got from the printer, and we're going to attach it to the star piece from the 6 holes that I designed in CAD that should perfectly line up. Also right now, I'm going to spin the motor to its maxed out side so I can put on the arm and it'll have a full 180 rotation without hitting the side of the arm. Boom, that's all 6 screws tightened into the star piece. Now we're going to put on my assistive piece that goes on the other side of the printed piece, screw it in so then it can have a circular motion without putting any stress on the servo motor in a sideways fashion. Now that I have the upper arm attached to the lower arm, I think it's time to clear out the mini servo deck area and put in the 2 mini servos to see how they fit. Both servos slide in perfectly, but one of the servos is slightly higher than the other. I think there's just some leftover residue inside the print. I'm going to push a little bit hard and see if it fixes anything. That looks like it did the job. Now I'm going to tighten both servos into the piece. Now that both of the servos are in and fastened, it's time to get the claw pieces ready so I can put them onto the servo. This is probably going to be one of the most annoying parts because I've never dealt with these claw pieces yet. So the claw piece doesn't want to sit in there properly with one side sticking uneven, and I think that's going to create a little bit of an issue, and if there's enough force the claw might pop off. So I'm going to take my smallest drill bit and one of my smallest screws and drill a hole into where the hole is on the arm bit and then screw the piece in to the printed part. Now that I drilled the hole, let's try putting a screw in. So that didn't quite go how I wanted it to. I think the screw hole I picked was too close to the piece where it attaches to the servo, and it kind of pushed it up so it would make the claw go in at an angle. So I'm going to take this off and then screw another hole in the hole over so hopefully it doesn't touch the piece and it keeps it flat. Now that we got the piece out, let's put the new hole in. Now that that's done, let's put it in and see if it works. Now that the first piece is all ready, let's get that second piece done. That second piece fit even better than the first piece. So now that I have both done, let's put them on the servos to see how they look. And again, I'm doing that lockout method so I can get the claws when they're plugged in to rotate to the full extent I want them to, so they do not push against each other too much, but also have the ability to clamp in a little bit. Honestly, this is my first time seeing these things on the robot in person, but I think they look just how I want them to. I just sketched this up real quick this morning, but I really like it, and they have a lightweight but like good grip. Obviously, I'll adjust it as time goes and I see something's wrong with it, but I like how they turned out. Now let's go back to that base I showed you guys in the beginning of the video. Now I see a massive issue wrong with it here. This robot feels insanely top heavy, especially with the two motors sitting in the front. And currently my design with the base is that it just goes on, slides in with no like support or any screws at all. So I think I'm gonna have to do a massive redesign on the base here, maybe with a double level cap to hold the base steady so it can't tilt over as much. Because I don't really want to tune down the weight on this thing. I kind of like how it turned out. I think I should just ramp up the bottom part so I can make it really nice and so it can at least pick up some decent level objects. Even though I know this is top heavy, I still am going to put it onto the motor to see how it works and if it really is bad. But I'm not going to put it to the limits because I do not want to strip the part. I think you can see the result I got from my face in this clip. Yeah, the part was way too top heavy. I could see plastic shredding off of the piece just from putting it on there without even moving the motor. So I knew this was not going to work. So it's time to go back to the drawing board. So now what I'm going to do to test the strength and durability of the claws, I'm going to use the arm not attached to the base because I don't want to risk stripping the part because I already did that once with my old design. And I'm going to just see if it can pick up an object without, the base turning motion, just me holding it. So let's see how that goes. Now that I wired in the main joint motor, I'm just going to move it around to see what type of objects it can pick up. I could not wire in the smaller motors because I did not yet code that, and the cap that I printed had some errors, so I was not even able to put on the cap, so the motors wouldn't have worked without maybe me ruining it. So that also has to go back to the drawing board. Alright, so I tested out the motor, and honestly, it looks great. I think the design worked pretty well. It doesn't look like it's making any wear or tear, and the design looks pretty efficient. As you can see, I pick up a cup here, but in the process of picking up the cup, I kind of kill the robot. So yeah, I took out the wires. So I think that this has been a great part 1, and all the issues that we know now, we'll tackle in part 2. But just to transition over to the next video, let's talk about exactly what I need to fix. Number 1, the base. We know that the robot I have made is very top heavy, so we need a wider, more stable base that can carry this thing so it's allowed to move as much and heavy as it wants, because we do not want to limit just because we want to make it work. 2, we need to fix the cap. I want to make some sort of clip system so I can clip in a cap and make it more efficient. My problem here was that I did like a cover that had to screw on, it would go on the other side, but the issue was that this would be very hard to put on, especially with the claws in the way. So we'll fix that next time. And 3, we have to hide the wires. As you saw, I took out my own wires, so we have to fix that next time. But it's been nice filming this video for you guys, and please tune in for part 2 where I'll go over what I learned and get the final product. See you guys.